So thanks everyone for being here. It's my pleasure to participate to that EPIC meeting. It's been some time. I haven't done an EPIC meeting. I see it's still as active as it was some years ago. And thanks for inviting us to discuss about beam shaping and how we have actually demonstrated that there are some beam shaping options, modules, products that can be essential if you want to be a world leader in battery manufacturing and in e-mobility in general. So this is the outlook of what I want to discuss today. I will be quite quick on the first parts about Cailabs and beam shaping technologies and spend most of my time on the process results. And then I will shortly conclude with what we are developing and what we will be developing in the future. So Cailabs, in a few words, for those who don't know us, we are a company based in France. We are more than 130 now in the company. And this is our building in Rennes, in the west of France. And we are specialized in beam shaping. From the beginning of the company, it was funded based on a unique technology, multiplane light conversion, which is then developed for a lot of different markets to address the potential of beam shaping. Along the way, we have actually identified that there are three main topics on which beam shaping is useful. Historically, we started with fiber networks, and we managed to improve a lot the data rate with beam shaping. Then more or less simultaneously, about 5 years ago, we have opened two new applications. One is space communication, the product you see on the left. The idea is to communicate with satellites, typically all the Starlink satellites, with laser. Currently, it's done with radio frequency, and this is our biggest market right now at Cailabs. And we are also developing industrial laser processing, which is our second biggest market, and which we will be discussing today. So the idea with industrial laser processing is to actually provide turnkey and customized solution in order to improve laser processing. And I will get back to what means improve later on. So we have been working on a lot of different applications. And again, we try to focus on where we have the biggest impact. And we have currently identified that there are three topics on which beam shaping is really strategic for the further development of the application. It's welding, microprocessing, and additive manufacturing. So even though I'm quite happy to discuss about all those topics, I will be focused on welding for today. So beam shaping technologies. So you did say it already a few times, Antonio, even though it's only 3:37 here in France, beam shaping is more and more discussed, and there are more and more beam shaping options. So let's try to shortly just review what means beam shaping. First of all, why we need beam shaping? Well, after working for a bit more than 6 years now at Cailabs, there is one thing that I'm sure of, is that it's nearly always possible to improve process with beam shaping. But you have to actually go through a certain thinking to find a good solution for your process. The first question is, what exactly do you want to improve? I insist a lot on that, but that will be a real part of my talk today. I want to insist on problems that the industry is having and that beam shaping can actually solve. So once you have identified a problem that you need to solve to improve your process, then you need to figure out what is the best shape to solve, to tackle that problem. Then when you have defined that the good shape to tackle that problem is whatever shape, let's say it's a triangular shape, what mean a good triangle versus a bad triangle? It's also very difficult, but it's quite important to identify what are the criteria which are important to improve your process. So typically, is it important that you don't have higher orders, or is it not so important? Is it important that your shape is actually really homogeneous, or is it not the main criteria? All those discussions have to be made at some point. Once you know what is the good shape and what makes the shape a good shape, you need to think about what is the best technology to do it. There are a lot of different technologies, and because the way the beam shaping is made, actually your capacity in terms of shape, but in terms of robustness and also in terms of price, are extremely different. So then only you can identify what is the best technology for your process. And in the end, it all comes to, will it cost you more than what you are saving in terms of money? And even though I will not address that part today, it's for sure an essential question that everyone has to address at some point. The idea is obviously to help our customer to make money. It means either improve the quality. It's quite important to know that beam shaping can help for a lot of things that maybe are not so obvious as a start, like improving mechanical properties, process more complex parts. All that is possible with beam shaping. But I have to admit that most of the time we try to go faster, we try to improve the yield. It can mean actual more speed in the process, like welding faster, but it can also mean removing steps in the whole process, like removing pre or post-processing, which is having actually a huge impact in the end on the whole time of the manufacturing process. So as I said, there are a lot of beam shaping options in the world, more and more every year, actually. But I want to try to divide those types of shape into two big groups, the one which are inside the laser and the one which are outside the laser. And typically, I help you a little bit on mapping everyone. This is just, it's not covering the whole world, but I would say those are some big ones. You have multiple fibers, which are not all made the same way, but in the end, basically you can make a ring and a dot. Then you have current beam combining, which is in the end dynamic beam shaping, so it's a beam moving very fast. And then you have a lot of ways to do beam shaping, which are not inside the laser. So in that case, you are more or less free to use whatever laser you are having, and you are implementing the beam shaping after the laser inside a module or inside a laser head. And all those technology use different way to sync the system, but also way to manufacture it. And in the end, it gives different performances. I don't have time to discuss all technologies, unfortunately, today, but I'm quite happy to discuss it if you wish to reach me by email. And I will focus on explaining what we Cailabs are doing. That's what we were doing 10 years ago, multiplane light conversion. The idea is to do freeform beam shaping, any kind of shape, but we also managed to tune the phase profile. So it means that you have a shape which is having a plano phase in the process plane, which is extremely important if you want to have an extended depth of field. And we do that based on mode propagation, which is a system which is fully reflective. And what you see on the right is how it looks like when we develop projects for laser processing. So it's implemented in between the laser and the process. It can be fibered or free space, and it's compatible with all lasers. I generally now like to say that I say there are so many technologies, like there are so many ways to make a laser, fiber laser, diode laser, disc laser. And after some years, it's been identified that some welding are best to do with some type of laser. I expect that one day the same will happen with beam shaping, and we will have a clear map of what beam shaping technology is best for what process. But this map doesn't exist yet. But just to say, at least what we Cailabs propose is compatible with all type of laser, monomode to diode lasers, CW to ultra short, and all wavelengths. And this is an apple on the left, a carrot on the right. So I was recently said that we shouldn't say apple and carrot, I should say apple and pears. Well, actually, we sell even something different in France, and we did not all agree on what vegetable I should compare when I say it in France. But one thing is sure, you have to be careful when you compare technologies, because the way they do the beam shaping is super different. So it's really not that easy to compare. So I will not say that I have a clear answer on how we should do it, but at least I want to stress the fact that it's not so easy to do it. Being said, so there are a lot of ways to do beam shaping. We have our own way at Cailabs. But why is actually beam shaping really a game changer if you want to be a world leader in e-mobility? Some process results. I will be going through a lot of different applications, and I don't want it to be a too technical presentation, so I will not be detailing all the process parameters and dimensions and setup and all that. So all my slides will be organized in that same way. You have an image of the process on the left, an image of the shape on the right, all the details about the process on the left, all the details about the shape on the right. I let you read. And even though I speak very fast, you are all reading faster than me. And I will then insist on why that shape can improve the process and why is it actually useful for the industry. First, we will start with some result that we have had with a ring dot shape that is implemented inside that module that you see on the right. That module is actually fully compatible with all Precitech laser head and equipment, and you can actually buy it from Precitech. So if you want to get some quotation from that module, you should rate Marcus, not me, because I'm not able to sell it to anyone else in Precitech actually from now on. So how it's implemented, you have the collimation, which is from Precitech and focusing, and in between you have a beam shaping module, which is made of two mirrors. And those two mirrors are actually doing the beam shaping. So why can we use that shape? So we have been actually trying to address all the biggest application of e-mobility and trying to see what the use of beam shaping for each of them. We started with hairpins, which is a quite classical application, which were made of copper. And in that case, actually, we wanted to focus on the spatters. Spatters are really critical when you do hairpin welding, because you don't want to have spatters going to another hairpin further, and in the end having shortcuts in your electrical circuits that can make the car burn or whatever terrible that could happen in that case. So we managed to demonstrate by just changing the beam shape from a standard shape to a ring and dot. We divided the spatters by a factor of 2. And this is actually super, super important if you want to increase or to reduce the scrap rate, to increase the yield of your manufacturing. We were also looking at bus bars. So we started with the motor, then the bus bar are connecting actually the motor to the battery. And in bus bar, it's also essential to apply beam shaping if you want to manage a higher gap. But it's quite known also in e-mobility that you need a zero gap welding. Well, it's not that true. It's possible to manage some gap, and beam shaping is really helping a lot when you want to do that. And if you apply the proper shape, you manage to actually increase the gap that can be accepted, and that gives compliant results by a factor of 1.5 compared to no beam shaping. And this is actually extremely important if you want to simplify the fixtures. Fixtures are complex and expensive and long to manufacture. So that's actually an excellent way to make your production more flexible and to make your production simpler. The motor, then the connection to the motor, then we go to the battery itself, so cell contacting. So in that case, we were working with the only battery module which we could communicate about, because most of the time it's super confidential. So that module is developed by Fraunhofer LT. And as you all know, it's quite, you have seen probably electric cars in the streets. So it's been existing for a long time, and there are ways to do this cell contacting, but the most common way to do it is to use what is called wobbling. So wobbling is doing a lot of little circle during the process. And I was quite strict with our partners, and I said, don't do wobbling. Whatever you do, don't do wobbling. We want to replace wobbling with beam shaping, and it works. And if you don't do this wobbling when you are doing the cell contacting, you can actually increase the speed by a factor of 5. That's, of course, excellent to increase your manufacturing yield. And again, regarding the bus bar, there was one last point that I wanted to stress, is that you can also weld deeper. If you have an extremely stable made pool at a fixed power, and I insist at a fixed power, because if you have more power, of course, it's easier, but you can slow down the process, which is super difficult, keep a stable keyhole, and manage to weld deeper. And in that case, we were managing to weld 3mm over 3mm at 8 kilowatt. Why is it so useful if you want to be a world leader? Well, it enables to have a more flexible production. With the same laser, 8 kilowatts, the same beam shaping module, you can adapt to a lot of different configuration, from not deep weld to deep weld of copper. It's working in any case, and it's extremely nice to have a flexible production. I will shortly mention some other application, because I think that it's good to talk a little bit about copper, because it's a classical topic of e-mobility, but we have actually worked on other parts of the vehicle as well. And in that case, we have developed a solution which is a hybrid laser arc welding with a ring shape and with an arc which is added to the laser head. This is the laser head with the connector, collimation, shaping mirrors, and focusing optics. And in that case, for now, we have been working on steel, but we will extend to other material in future. And the idea is, again, to manage higher gap. So it's definitely possible with a ring shape to increase the gap which is accepted when you are doing thick welding. So in that case, we were actually welding steel plates of 28mm thickness, which is excellent actually to compete with arc welding. So it's very difficult to switch from arc to laser, because of a process which is maybe a little bit more challenging, but it can also be more reliable and more efficient. But you need to have something which is very robust, and beam shaping enables that. And on a pretty similar application, we also demonstrated that you can increase the speed by a factor of 10 by using laser and arc together for that process. which is obviously very good for manufacturing capability. So I just want to say that there are a lot of other shapes that can solve a lot of other problems, like typically managing all the cracking issues in the complex aluminum, managing gaps in linear welding, a lot of different problems, and there will be a lot of more results in the future. So follow us and look at what we are developing. We are really trying to address a lot of different issues with our beam shaping solution. So this is just the beginning. We actually work on having systems compatible with more power. We want to have combined functions. We want to have dynamic system. It's already under development. We did it at R&D stage. We have to make a product out of that. We work on new wavelengths as well, complex shape that are not possible with other beam shaping technologies. And we also work on new applications. So my conclusion now, I think that I did show it today. It's really possible to upscale laser welding with beam shaping. We are really providing solutions for a lot of issues of the industry. And I always insist people to think out of the box. There are a lot of possible shapes in the world, and it's not clear yet what shape is the best for what process. So keep bringing us problems, and we will try to keep bringing you solutions. And this is it for my presentation.